So hello S4, hope you're all doing well. In today's new work I want to do a very quick recap of everything we've looked at with vectors so far. So in this situation here you'll see that we're given the point A, which is at 4, 1, so 4 along the x-axis, 1 up the y-axis. If we draw a vector then from the origin to that point A, then reminder this vector there, which we're going to call A, describes the journey from the origin to point A. So vector A, when we talk about a journey from the origin to a point, let's call that actually OA, what we're talking about there is a position vector. So we've met position vectors before, and the components of this position vector to get from the origin to A is simply describes my journey. So it's 4 along the x-axis and 1 up the y-axis. So my vector A, position vector OA, has the components 4, 1. In this one over here, we're going to deal with a new vector B. We're told its position vector, the components of that are negative 2, 3. So what that tells me is I would start at my origin, I go back to on the x-axis because it's a negative, and then I go up 3 on the y-axis. So the point B is going to be here at negative 2, 3, and now I have a position vector to get from the origin to point B. Remember, it needs a direction, so please remember to use these arrowheads, and that is now vector B. So a point in space, we can give it components of a vector, the journey from the origin to that point. The other things that we've looked at then, we should be able to do a bit of vector algebra. So for example, if I was asked to do, let me just get a pen that works here. If I was asked to do A plus B, then we know that just means take the components of A, which are 4, 1, and add it to the components of B, which is negative 2, 3, and then I can add my x components to get 2, and add my y components to get 4. So that would be the resultant vector journey if I was to take vector A and add it to vector B. Very quick sketch, might A look something like that, B something like that. So is the journey from this point to that point my resultant vector A plus B? Does it look like that could be 2 along and 4 up? Yes, it does. So that makes sense there. You should also be able to multiply by a scalar. So for example, 3a, if I wanted 3a, that just means 3 times the components of a. So it would be 12, 3. So that's just doing vector a 3 times. I'd have to go 12 along and 3 up. And then the last thing you should be able to do is find the magnitude of a vector. So we found vector a plus b here. Our notation for magnitude, just 2 vertical lines either side of that. That basically means we're about to find the length of, this new vector a plus b here. If it's got the components 2, 4, we know we can use a bit of Pythagoras. We do 2 squared plus 4 squared, 4, 16. So I'd get the square root of 20. And maybe we would have to simplify this down. So our surge work tells us we can write this as root 4, root 5. And then the square root of 4 is 2. So the magnitude of that would be 2 root 5. So there's a very quick recap of what you should be able to do at the moment with vectors. So what we're going to move on to looking at today are 3D vectors. Now obviously in real life we live in a 3D world, so at the moment our x and y axis is great for me defining any point on this board. So if I had a point here, maybe that's 10 along, 7 up. If I've got a point down here, maybe that's 25 along and 4 down. Okay, so I can do that. But what if my point isn't actually on this board? This is me on the board. What if my point is up here somewhere, off the board? Or what if the point is closer to the floor, into the board, sort of through the board? So we need to introduce a third direction. And the way that we do that is quite difficult to draw when I'm drawing on a 2D board like this. How do I show that direction that is just going straight in and out of this board? And what we do is we just draw a sort of third axis in here at 45 degrees. And that axis, although it doesn't look it, that is going straight in to my board. So if I follow the positive direction of this axis, I'm going into my board. If I follow the negative direction, then I'm coming out of the board, or off the board, as it were. And it might be nice if these were still called X and Y, but what we actually do is we imagine our original X and Y axis, we've knocked it over, and it's now become the floor of this. So this is now still my X axis. This is now my Y axis. So that one that used to point vertically, imagine it's just been knocked and it's falling on the floor now. And this third axis is my Z axis. So we've got X axis going left and right, Y axis going in and out of my board, and my Z axis going up and down. From there, all we do now with coordinates, with vectors, is we introduce that third dimension. So if I had the point A and it had the coordinates 3, 2, 5, so that's how we write the coordinates. We're used to just two of them. We're now introducing the third one. That basically means that the point A is 3 along my x-axis. This is now my y direction into my board in a positive way. So that goes in 2, and then the z direction vertically up 5. So that puts my point A here. Now I know I'm drawing it like it's on my whiteboard, but it's not. It's gone into my whiteboard 2 units. Okay, so that point isn't really on my board, it's in behind it. So that's my point A, which is 3, 2, 5. And now if I was to talk about the position vector of it, I would draw my position vector in something like that. Again, it looks like that's on my whiteboard, but it's not. It's really going into my whiteboard. So that vector A, it now just has the components 3, 2, and 5. So we're just introducing this third dimension, but our notation all looks the same. We just have to take account of this Z direction. So if I had a similar vector, let's see if I've got a green pen handy that works. Say I had another vector B, and maybe it had the components, I don't know, 4, -1, -2. That basically means from the origin, I would be going 4 along. -1 in the Y direction means I'm coming off my board, but we would draw it in that direction. And then -2 in the Z direction means I'm going 2 down. So that would be me 4, -1 off my board, and then -2 vertically down. So this is my point B here. That would obviously have the coordinates then 4, -1, -2, and its position vector from the origin, something like that. From there, everything else you've done with vectors is exactly the same. You could now be doing resultant vectors, so I could be doing A plus B. All I do now is exactly what I was doing before, but I've got X, Y and Z components to add together. So I'd be doing 4, -1, -2. So my resultant vector would be 3 plus 4, which is 7, 2 plus -1, which is 1, 5 plus -2, which is 3. So my new vector 7, 1, 3, that would be 7 along, 1 in the Y direction, and 3 up the Z axis. I can also find magnitudes. I'll go across here just to do that. If I was asked for the magnitude of A plus B, well, we're dealing 3D now. Remember your 3D Pythagoras. We have got a quick way of finding the magnitude of a line in 3 dimensions. We just take its X, Y and Z components, square them all and add them together. So in this case I would be getting 49 plus 1 plus 9 for the square root of 59 as my magnitude. So there's an introduction to 3D. Once you've got your head around this new dimension in and out of the board or in and out of your jotter page, everything else is fairly straightforward. And there's a good exercise in the textbook that kind of just takes you through that, and that page number and the questions I would like you to do are coming up just in a second. So in your textbooks, there's a good exercise on page 150 to 151, exercise 15.7. I would just work your way through this. It takes in sort of the full range of questions. Each question is kind of slightly different to the previous one. So I would just, as I say, spend an hour working your way through that exercise. Have a look at the examples that are at the top of page 151. 150 if you need a bit more help. And spend an hour, correct your work, and then just upload it to our team's assignment.